All right, today we're breaking down a recent scientific paper that looks at a really drastic proposal to fight climate change. We're talking about a technology that could cool the planet, and fast. But it comes with a seriously heavy price tag and a pretty profound warning. And get this, that warning comes straight from the paper's author. This one sentence really captures the whole conflict we're talking about today. It's a terrible idea that might just be the only thing that saves us from a worst-case scenario. Wow, that is quite a place to start. So yeah, these are the big questions, right? What is this thing? And why on earth are we even talking about it? Let's dive into the science and the stakes behind this pretty radical idea. To really get why anyone would even consider something so risky, you have to understand where the author is coming from. The core premise is that our slow reaction to climate change has pushed us right to the edge of a mass extinction event. And that level of desperation, it's what forces these extreme ideas onto the table in the first place. And that idea is called solar dimming. Basically, the plan is to mimic a giant volcanic eruption. You'd spray tiny reflective particles, aerosols, way up into the high atmosphere. These little particles would act like a kind of planetary sunshade, blocking just a little bit of sunlight and cooling the Earth down fast. But the author is super clear on this. This is not a solution. It's an emergency stopgap, a risky, temporary break, and that's it. But here's the catch, and it's a huge one. This emergency break comes with two absolute, non-negotiable conditions. The author says solar dimming is totally pointless unless we do two other massive things at the exact same time. One, we have to aggressively stop pumping carbon into the air, and two, we have to go all in on pulling existing carbon out of the atmosphere. Doing the dimming part alone, it's just not an option. Okay, so let's just say we had to do this. If we were forced down this road, what would we actually spray up there? This leads us to the next huge question. How do you choose the right material? Or as the paper kind of frames it, how do you choose your poison? So the paper looks at a whole bunch of different candidates, and every single one has major pros and cons. You've got stuff like calcium carbonate, which is great because it's alkaline and won't cause acid rain, but it falls out of the sky too fast. Then there is crushed basalt, which is everywhere, but it takes a ton of energy to prep. But what I really want you to look at is the bottom of this list, sulfur dioxide and diamond dust. The author ranks these lowest for some very, very good reasons. And sulfur dioxide is just this perfect cautionary tale from our own history. We know it works. The 1991 eruption of Mount Pinatubo shot a bunch of it into the stratosphere and cooled the entire planet. Proven concept. But we also know its terrible side effect. That same chemical process creates sulfuric acid. That's what caused the devastating acid rain crisis in the 70s and 80s that killed off forests and wiped out fish in our lakes. The paper basically argues that deliberately causing that catastrophe all over again would be just unthinkable. But here's where it gets really tricky. Even if we found a perfectly safe material to use, we slam right into this deep, kind of ironic problem. The paper calls it the dimming dilemma. The very act of blocking the sun actually hurts our best long-term tools for fighting climate change. And here's the most obvious example. It's really simple. If you dim the sun, you reduce the power coming out of every single solar panel on the planet. The relationship is almost 1-to-1. So a 1 to 2% drop in sunlight means you get a 1 to 2% drop in global solar power. Period. And it's not just solar. Think about wind. What makes wind blow? It's the sun heating the Earth unevenly, creating temperature differences. So if you cool the whole planet down with solar dimming, you weaken those temperature differences. And weaker temperature differences mean less wind. The models in the paper suggest this could cut global wind power by anywhere from 1 to 4%. Now, these might sound like small numbers, but they create this really dangerous domino effect. When you have less power coming from solar and wind, you have to rely more on backup power, which a lot of the time is still fossil fuels. It makes us need more expensive batteries, and it makes the financial argument for building new renewable projects just a little bit weaker. So, in short, the very act of dimming the sun could actually slow down our switch to clean energy. It's a real paradox. So, where does all this leave us? What's the final verdict from the author on this incredibly conflicted technology? Well, after weighing all the pros and all the cons, the paper kind of reluctantly lands on silica. Yeah, basically a very, very fine sand. It's definitely not a perfect choice, but it's chemically stable. That means you avoid the catastrophic acid rain you'd get from sulfur dioxide, and you don't have the toxicity worries you'd have with things like nanodiamonds.
It is pretty much the least bad option on a list of bad options.
But even with this best candidate, the author leaves us with this incredibly powerful metaphor. Solar dimming isn't a cure. It's like putting a temporary band-aid on a sliced artery. It's a fleeting, weak effort that does absolutely nothing to fix the real problem, which is our carbon emissions. It might stop the bleeding for a minute, but it can't heal the wound. And that just leaves us with this one giant question. As we look at a warming world, we really have to ask, is a radical move like this a necessary bridge to get us to a safer future? Or is it just a dangerous distraction that actually hurts the very tools we need to build that future? The paper doesn't give us an easy answer because, well, there isn't one.